Good evening, everyone. So, I welcome all of you to the second day of the free session of Sky Skill Academy. So, with us, trainers Damodar sir have already joined. So, we will actually wait for 10 more minutes to give some time for other students to join. Good evening to everyone. So my name is Tanmay Chandra Dalai. So I welcome all of you to Sky Skill Academy's free sessions. So today is the second day of the session, and as I told you yesterday by my colleague Simran Kaur, that today's session will be an interactive session. So I would request all of you to kindly stay muted till the end of the session, and then after the ending of the session, we will have the Q&A for your doubt clearing sessions. Okay. So Damodar sir, I think we can start the session.
Uh, yeah, cool, sir. I can start. But uh, can you just put a reminder for other people also? Because the quantity of people are less today. Yeah, cool. No issue. So, good evening, guys. So, let's start. So, in the yesterday's session, I have briefly gone into the CAD definitions, the impact, the drafting formats, and those basic things I have already gone. So today I'm going to show you a practical thing and how this will be impacting your manufacturing thing. Okay, so that thing I am going to show you today. Okay, so let's start with a very simple project. Okay, so initially I have to understand, sir, what I'm going to make. So I have to make a bracket. Okay, so I'll have to make a bracket. So what will happen over here? Let me make it in 3D so you people can easily understand this thing. Okay, so what I need to do over here, sir, here there will be a hole. Okay, so that is the hole for a motor mount. Okay, so the motor shaft will be there, and here the motor will be there. Okay, and we have to provide some of the hole so that I can do the. Okay, so on the motor actually we are having some number of holes. Okay, so we can directly screw it. Okay, so first understand the basic requirement of the part, then we will go forward. Okay, what else is there? Sir, this has to be mounted on a particular base. So there is a base. Okay, so we have to mount it over here. For that mounting position, we need some hole. So here I have given 4 number of tapping hole. Let's say it is M4 ka tapping hole. Okay, so what we need to do over here? Sir, we need to give some hole over here. Okay, 4 number of holes over here so that we can attach a bolt. Okay, and we can tighten it. Okay, so this is the requirement of this project. So what are the data we are having with us right now? Okay, sir, we are having a L bracket. Okay, so this thickness will be around 10 mm. This thickness is 10 mm. Okay, this length will be around 80. Okay, this will be around 100. Okay, so I'm going to make this model first, then I'm going to show you, sir, how we are going to practically implement it in the industry. Okay, so initially I'm going for a sketch. Okay, so this dimension will be how much? This dimension will be 10 mm. Okay, and this length will be how much? This length is 100. Then how much height? Okay, height I have not provided. Let's take the height as 80. Okay, so from here to here, I am providing this as 80. Okay, okay. So the first L bracket I have already created. Right now, what I need to do, sir, I need to provide the mounting for the motor. So for the motor rotation, actually, I need a small bearing. Okay. So on the motor, I need a small bearing over here. Okay. And then I have to attach it from the bottom side. So if you see over here, sir, I have already found out a bearing. Okay. So SKF is a side. So from this side, actually, you can easily find out so many types of bearing. So it is a standard, a very standard company. Okay. And very qualitative company. So in that one, you can easily download the CAD for this bearing also. Okay. So from that one, if I want to see, sir, the basic dimensions are already given. The bore diameter will be 8. So ID will be 8, OD will be 16. Okay, and width will be 6 mm. So what I will need to do, sir? Sir, I will have to go to the bottom side. Okay, and what I need to do over here? Sir, I have to do a circle. Okay, just a minute. Okay, so I have to draw two number of circles. Okay, one is how much? Sir, one will be 16. And another will be, let's take around 8. Sorry, let's take 10. Okay, so from the model, I can provide the tolerance. Any of the H7 is okay. Okay, so then what I need to do, sir? I have to go for extrude. So the thickness of the bearing is how much? Sir, it is 6 mm. The width is 6 mm. So I have to go 6 mm and you have to subtract. Okay. So the bearing can be entered, but again we need a through hole for the so that the motor ka shaft can go inside. Okay. So the motor shaft can go inside. So we need a through hole. Again the same sketch I am selecting. Again I am selecting the extrude. Okay. So in next, what is the benefit over here, sir? We can easily select the region over here. So the same previous sketch I can select over here and I can select the region. Okay, just okay. So directly I'm able to select this thing, but this flexibility will not be available for other. Okay, and subtract. Okay. So right now all of you can see that we have made a space for the bearing. So I can hide the sketch right now. Okay. So the bearing will be coming over here and it will be set over here. Cool. So next what we need to do, sir? Sorry, we have not given the position. That is the most important thing. Okay. So I'm giving it at the center 40, and from here I'm also giving 40. Okay, slightly offset. Close. Okay. Next, what we need to do, sir? Sir, for a model, we need to give some mounting holes. So the motor which I am using, so that is having 6 number of mounting holes. Okay, so those data you can get it from another electronics team or any other team who will be working on that one. And because the motor is a bought item, so that's why I'm not going to make the model for it. Okay, so okay, I'm going for a screw clearance so that the screw can pass. Okay, I have to give the position, but before that, the size should be M4. So I'm selecting the M4 size. Okay, it should be a simple hole. Okay, then I have to select the position. Just Yeah, I need to select a point, so I'm placing a point. Okay, the count will be 6 numbers, and the center point will be, okay, I'm selecting this particular point, going for OK. Okay, and 6 number of holes will be made. Okay, and the pitch circle. Okay, the pitch circle I have to define over here. So let's say that is 40. So in the pitch circle 40, I have already made 6 number of holes. I'm going for finish. Okay, as all of you can see that there are 6 number of holes has been already made. Okay, next what I need to do, sir, I need to go for making the holes for holding all the system over here. So guys, there is one more thing we have to do, sir. Here directly holes we cannot provide, sir. We have to provide some adjustments. So for the adjustment we have to provide a slot so that we can adjust on this particular direction. Okay, let's make the similar over here. And because we are using the M4 bolts over here, so which I have already defined over here. See, sir, we are going to use the M4 ka bolt. So what slot I have to make or what hole I have to make? So you have to understand that thing. For that thing, you can easily search in Google M4 socket head screw dimensions. Okay. So if you see over here, so easily you can get this data from online. Okay. So the head diameter is showing us 5.5, but it will be more actually. So it depends upon the brand. So if you see over here, sir, it is showing us 7.22. So you can consider 7.5. Okay. So what you need to do, sir, again, we have to go for sketch. We have to select this particular plane. Okay. So at the time, I am making 2 number of circle. Just to switch off this continuous auto dimension. Okay. So already I have made a slot. So there are so many other features are also available. So I can just use them. I'm just clicking on OK. I'm deleting this particular dimension. So for the M4 size, we have seen, sir, we have to create a slot for 7.5. So I am writing here 7.5. Okay, so we have to geometrically make it constant. Cool. Okay, so this one is 7.5 and the internal will be how much? So the internal will be 4.4. So if you see the screw size over here, okay, any screw size. So M4, okay, just a minute, not over here. So let's write M4 clearance hole. Okay, okay. So if you want to see the M4 ka clearance hole, so what will the drill size will be there? So see over here, so it is 4.4 normal fit. If you see over here, so it is 4.4. So that is why I am making it 4.4 over here. Okay. Then what else we need to do, sir? Sir, we need to give from this center to this center how much the value will be. Let's take, we have to adjust 5 mm. Okay. So again, what I need to do, sir? I am going for okay. There are two reference lines are there. Again, I'm going to use another feature that is called as the mirror. So I'll have to select them. The center line will be this one. Apply. Okay. Then again, I have to select this one and this one. Again, the center line, this one. Okay. Right now, I have to set the dimension. So from this one, so from this one to this one, the dimension I'm setting as 40 mm. Okay. From this particular center to this particular center, I'm making it as 50 mm. Cool. So right now, we have to select the extrude. Okay. So here the selection procedure helps us so much over here. Okay. So we can easily select boundary region. Okay, again, just I'm finishing the sketch. Okay, so this I'm selecting the region boundary. So I'm selecting this boundary, and this boundary. So it should be through cut. So I'm clicking on OK. Okay. And if you see the head diameter, So that is 4 mm. So I'm selecting again, so making this one as 0. And this is -4. Okay, just select this boundary, this boundary, this boundary, and this boundary. And click on OK. Okay, right now I'm hiding the sketch. Okay, so all of you can see, sir, I have given the slots over here for the adjustment. So this is the overall model. But also you have to understand, sir, we cannot keep the sharp edges open because it will be harmful. So you have to give some blend. We have to provide some fillets. Okay, so let's provide the 5 mm of fillet. So I'm selecting this edge, this edge, this edge, and this edge. Okay, okay. Also, I can select a small edge blend or the fillet over here because it is also a hard surface and it is a sharp surface. Okay, so right now, sir, it is fully smoothen. Cool. So this is my project. Okay, so this is how we have to think. So whenever we are developing a project, we have to think in that way. Right now, sir, how to give the drafting of this one? Okay, so where to put the data? So that was the main question in the yesterday's session. Okay, so right now, what is important, sir? Sir, there is a L bracket. So if you see the bottom view, okay, sir, there is a hole for bearing. There is a hole for shaft. There are 6 number of holes over here. Okay, guys, I'm not going to show the drafting in the NX software because I have to go for manufacturing of that one. Okay, and if you see from this particular side view, so how it will be looking like? There will be slots available over here. Okay, so right now, sir, our this position is the reference position right now. Guys, understand this thing, sir. The opposite part, the motor and its mounting points are related. Okay, this motor shaft and these mounting points are related. So that is why we have to take this circle as a reference. Okay, sir, this circle as a reference. So this center line, and the vertical center line. So right now we have to give the datum over here, sir. This is my A. Okay, and this another vertical side I can provide, sir. This is my B. Okay, you understood? So from the A and the B, we can easily control this 6 number of hole ka positions. So we can easily give over here, sir. This is the position. Okay, with a very particular tolerance with, with respect to A and with respect to B. Okay, again, it is the wrong one. So we don't have to write like this. Okay, sir, the A reference will be this one actually, the bottom reference. Sir, this is the A. Okay, this is the B and this will be the C. Because from the bottom one, we are going to start the machining process. First understand. Sir, from the bottom one, we have to start the machining process. So that is why that will be the A reference, first reference. Okay. So right now, all the whole positions will be controlled by the position tolerance I am giving 0.02. Okay. So first surface will be A because on this surface we are machining. So that will control the perpendicularity also A, B and C. Okay. So whenever we are going to start a machining process, suppose we are having a block. Sir, initially we have to face this one and we have to set that one first. Cool. So which surface we are machining first, that will be our reference A always. Okay. Then according to the B and C, we have to control the position of this 6 number of holes. So we have to provide the PCD value. I think we have given it as 60. Okay. Next, what tolerance we can give, sir? Sir, whenever we are giving the A, so see over here. Sir, this A surface we are giving some length. Correct. So here we have to provide some this symbol. Okay, so the surface should be plane. It will be 0.02 initially. Guys, understood up to this one? See, sir, this surface actually we are going to machine at the first time. So that is why the planarity of this one should be 0.02. So it should be accurate first. Okay, so wherever we are giving the reference A, so that should be plane with a tolerance of 0.02. And after that, we can provide this one. Sir, this can be perpendicular with a value of 0.05 with respect to A. Guys, this GD&T, have you understood? How we have started giving the reference A, B and C? Or is there any doubt? Guys, can anyone respond, please? Okay, got it. Cool. Okay. So right now, all of you can easily understand, sir, from the design level and the drafting level, how it is controlling the manufacturing part. Okay. Okay, chalo. And because we are mostly focusing on this particular holes, so that is why there is a chance we cannot maintain this hole. That is why we are providing the slots. In case if you want to provide a horizontal slot, that is also fine. That depends upon the application. Okay. So that is why we have given it. So right now I am not going to give a particular drafting for it because time is less. So you have to proceed for the machining process. Okay. So the bottom machining we have to initially do. So let's try. So here we are going to use two number of machining operations. Okay, in a single machining operation, it cannot be done. So what is that, sir? So the manufacturing guy will be doing the machining. Okay, so he will be keeping a block. So initially he will be facing this much of surface. Then what he will do? Sir, he will do two number of holes for the bearing and the shaft wala hole. Okay, so here I'm going for this one. Okay, so initially what we need to do, sir? Okay, so initially we have to set the axis. Okay, so this will be my axis. So I want to keep my origin over here. Okay, so it's a inferred. Let's select this particular point. Okay, or else we have to drag it at that particular point. Okay, so my XYZ will be looking like this. Okay, the orientation is correct. I'm going for OK. Okay, some clearance value has been given. Next, what I need to do, sir, all of you can see, sir, right now the object ka coordinate system and the machining coordinate system, both are different over here. Okay, so initially I'm going to select the workpiece. Okay, I'm also going to select the raw material over here. So I'm going to select a raw material. All of you can see, sir, how easily I can make a raw material. Okay, so 5 mm, I'm keeping an extra for the facing operation. Okay, then I'm going for OK. So I'm going for creating an operation. So I'm going for a cavity mill. Okay, just a minute. I go through a wrong process. So here I have to select the operation like this. Okay. So automatically the raw metals will be generated. So I have to select this particular face, this face, and this face. Then I'm going for OK. Okay. Next we have to select the tool. So I'm going to use an end mill. Okay. So there are different types of tools. So we can easily use them. Okay. So again, the tool I have to change. Cool. So I'll have to keep it nearby it and some clearance value. And the diameter should be, let's take 10 mm. Okay, so this is how I have selected the tool. Let me directly go for the finishing operation. Okay, so there are some parameters we have to clear it out. Okay, feed and speed is very important. So I'm going to cut with a speed of 4000 RPM. So automatically I can calculate all the cutting forces and everything. Sorry, I have to provide over here. So this will be 4000, and we can easily calculate the other forces, surface, feed for tooth, everything will be calculated according to that. So I'm going to generate the program. So see how easily we can do it. So it is creating a program. Just wait for it. Okay. So there is a error. What error is that? Sir, we are using a hole around 8 mm. So our tool cannot exceed from that one. So our tool should be 8 mm. Or let's take 6 mm. 6 mm will be good. Okay, some clearance value. Then the tool is fine right now. Again, I have to generate the program. Okay, right now the program is correctly generating. Okay, there is another issue. Can we ignore because they are two? Okay. Okay. So right now see, sir, this is how my raw material will be looking like. Okay. So I can easily simulate it and I can see, sir, what will be the problem. So that is why it is also a CAM, computer aided manufacturing software. So you can see, sir, how the tool is cutting the whole workpiece. So I'm making it slightly fast. Okay. So right now you can see, sir, this much of machining it has done. Okay. So the bottom things are not machined till now. So we'll have to do a separate machining for that one. Okay. And for this also we have to go for drilling and those operations. Okay. So I'm clicking on OK. Okay. So this is one attempt. So this is how we can do the operation from that back side. And if you want to do from the front side, what we need to do is, again, we have to set the workpiece properly. So we have done it in the opposite side. Right now we have to correct the size. Okay, so right now this is the position, and I will have to set it over here. Okay, and okay, the workpiece all are fine. Okay, right now I have to create an operation from the opposite set. Okay, so cutting area I have to specify this one, all these sides. Okay, and these are the main cutting areas, and this hole. Okay, and let's select the okay, so bottom holes cannot be selected. Okay, fine. Okay, so this much of cutting it can easily do. Okay, this fillet and this particular fillet. Clicking on OK. Okay, again I am going for semi finishing. Okay, let this distance be fine. The tool I can select this one. Or else I can create a new. Okay, just a minute. Okay, so for this tool I will have to select from here. Clicking on OK. The position is well set. Okay, I can right now change the tool path. So I'm using this one. Yeah, all the parameters are okay. Yeah, right now I'm generating the program again. Okay, so because we are using the two number of machines or two number of operations for it, so that is why we have to make it in two different settings. Okay, so right now if you want to verify, okay, you can easily verify. Okay, so again that hole is still remaining, so we can do another operation for it, so for making those holes. Okay, so this is how we can easily judge a thing. Okay, again we will have to delete the previous operation. Okay, so suppose we want to this see this thing through a machine. Okay, so we can easily call a machine over here. Okay, so there are number of list of machines are present over here, so I'm calling a very basic machine over here, so you people can understand, sir, how this thing can be done. Okay, so see over here. So because we have called two number of tools over here, one is of dia 10 and one is for 8, so that is why in the tool station there are two number of tools present over here. Okay, so the machining of basic funda all of you have understood. So right now the bottom surface has been machined and the bottom surface is fixed on this particular bed. So according to that bottom surface, this face ka perpendicularity, okay, these positions, everything will be maintained from the bottom surface. That is why the bottom surface was okay. So that is why this bottom surface was kept as surface A. So that was the first machining surface over here. Cool. So right now, if you want to see, sir, how on the machine it will be looking like. So we can see from here. Okay, just a minute. We made a small mistake. There is an option. We have to check that one. Okay. So right now it is coming with the raw material. So we can easily understand, sir, how it is cutting. So you can easily see the machine ka simulation. Okay. So right now the bed is moving in the XY direction and the tool is moving in the Z direction. Okay. So just wait. Right now the tool will be moving in the Z direction. See. Okay. You can see that it is jumping. I'm making it slightly fast. Okay. And this is how we can easily understand how it is the machining is possible. So where we need to put the clamp, every setting we can make it from here. And also, sir, how much time it will take? You can see the time updates from this particular window. Okay, for making so for machining this one, sir, how much time it will take? So you can get it from here. Okay, suppose I want to change the machine, so that also I can easily do. So whatever the standard machine I'm having, I can choose from the those also. So I'm using a 5 axis machine. Okay. So right now I have changed the machine. So right now you can see, sir, the setting of the machine is slightly different over here. So here there is no tool station is present over here. So we may have to manually change the tools, but that is a different thing. Okay. So right now if you are going to play, see, sir, this is a 5 axis machine and how it is looking like. Okay. So from here it can rotate, from here it can rotate, and the three direction X Y Z direction. Okay, so every way it can control. Understood, guys, how it is used in the industry, the CAD and the CAM. Okay, so these are actually extra things. So every time we don't have to go for the machine simulation. So by normal simulation, we can easily judge, sir, what machine we're having in our industry, and how the clumping has to be done, and how the tool setting has to be done. So everything we can judge easily. Okay. This machine simulation is for showing the clients for that how the machining will be done. So how much time it will take, what type of machine we are having for this advertising thing. We are using the machine simulation. But most of the time, directly the tool simulation only we have to do to judge whether it is going to fail or whether there will be any accident or something. So you have to judge from that one only. Guys, I hope all of you are clear. Or is there any doubt? You can ask me because the whole session is ending over here. So that was the pending thing which was pending in the yesterday's class. Guys, any doubt? Because the session is ending over here. If you are having any doubt, you can ask me right now. Areva, you people are having no doubts. Cool. So it's a good feedback for us, definitely. But guys, for the industry one, you people have to remember one thing, that is, sir, what are the dependency present over here? Okay. So as I have told, sir, there are dependency over this particular shaft and its mounting holes. And to adjust that one, we may have to provide some slots over here. So that is why we are providing the slots on the clearance hole, not on the tapping holes. Okay, so where we are having the independency, where we are dependent, so where it should be tightened, so everything we have to see. Okay, guys, do not just leave. Okay, Ali is asking, sir, I just select the area thread I want to remove and subtract it. Why we use this milling process? Okay, so there are so many options we are having over here, Ali. So when you will be entering into the industry, so which will be the fastest operation, which will be low costing operation, so that we have to see. Yeah, we can do every type of operation over here, not only drilling and milling. We can do the turning also, but I have only shown you the milling setup. Guys, do not leave the session. I think some declaration will be there regarding your attendance and feedback system. Vaibhav, I cannot literally say about the fixtures. Okay, so it will be time taking a very huge time to describe it. Okay, actually there are so many things because GD&T only the basic, very basic thing I have told, but there are so many other things. There are tolerances, how to convert the GD&T into the nominal tolerances. There are so many things will be there. Yeah, how to operate a angle hole. So if you are using, so which machine you are using, that depends. See over here. So if you want to make an angle wala hole, so if you are having 5 axis machine, so you can easily rotate this in a particular angle. So how much we are rotating, that is another axis. Okay. And this one, so where you have to do it, so according to that, this will have to rotate. Okay, so it depends upon the machine. So machine to machine, this thing will vary. So how to do angle hole and everything. Okay. uh so guys, from my side this much. If any doubts or anything, you can ask me. And just wait, I'm just informing. So you people will get some another, just wait for some time. Yeah guys, you